be on the many faces of Struct tags. And they come from two separate companies, but they must be really good friends. With that, let's give them a warm welcome.
All right. Again, this is Helman, and this is Kyle. And we're here today with the just incredible privilege of talking to you guys, doing a deep dive on a not often talked about feature of Go, Struct tags. So if you're in this room right now, you've probably seen tons of resources doing deep dives into different features of the Go programming language, stuff like error handling or concurrency primitives. But something that we've noticed over the last couple of years is in the community, there are barely any resources on how to deal with Struct tags.
So if you're like us, when you first started programming in Go, you probably went to the website and read through the effective Go document. It's linked on the official Go website. It's highly recommended to read, and the idea with the document is that it's a set of best practices for beginners to learn for utilizing the main features of the language. And it's extremely useful, it's a great read, but interestingly, it doesn't actually make a single mention of Struct tags. So there's a couple interesting implications of this. One is that people probably jump into the language without a lot of context on exactly what Struct tags are and how they should be used. And another interesting, maybe even more interesting implication is that perhaps there is no set of best practices. Perhaps there isn't a specific use case immediately in mind. So that leads into why we wanted to give this talk today.
Right, and so there's sort of two things we'd like to do here. The first is we want to explain exactly what a struct tag is and how to interact with them, and go through a series of sort of increasingly unorthodox examples where people have used them.
And the second reason is we want to galvanize you to maybe consider using struct tags for a solution to things that you might not otherwise use them for. They're certainly not a catch-all, they're certainly not a solution to everything, but they may have more uses than they appear at first glance. So, what have we built? What is our background in Go really?
Right, so what we built has a lot to do with why we're here talking about struct tags right now. Sam and I worked for a couple years on different Go projects at MongoDB. The two big ones that we worked on is Evergreen, this big distributed continuous integration testing system for testing the MongoDB server and other things. And then the other thing we did was a complete rewrite of the tools that ship with MongoDB in Go. These are things for doing backups, monitoring, stuff like that. And this is key because if you've used Go and MongoDB together, you know that the Go driver depends heavily on struct tags for communication. Additionally, we found libraries for things like configuration for config files or command line arguments that depended heavily on struct tags as well. And so at this point, we're pretty sure that we've used struct tags much more than most of the Go community, and it puts us in a unique place to give a talk like this one. So since this is a talk on a specific language feature, we figure it's probably a good idea to start at the very literal basics. Sam, what is a struct tag?
So let's go straight to the spec. As defined in the language spec, a struct tag is a string literal field coming after the definition of a field in a struct, and that's pretty much it. You can put anything that you want in that string literal, and it becomes attached to that field of the struct at compile time. You can't actually twiddle these struct tags and change them at runtime, which has an interesting implication. We think this is why this is the case, but struct tags actually take part in type identity for a struct. Don't really worry about this. It's incredibly unlikely that this would bite you, but it still is an interesting thing to note that normally you would be able to convert freely between these two structs because they have the same fields of the same type, but because the tag for priorities is different, you'll actually get a compile time error if you try to write this code. So, why are struct tags in the language?
Right. So the name struct tag probably cues you in a little bit to their usage. The same way that you might upload a video of your cat onto YouTube and tag it with the words adorable and cute. Similarly, you can tag fields of your struct with arbitrary sort of information denoting usage or just other things that external libraries might want to take advantage of. If you do struct tags at all, you probably use them for the encoding libraries within the standard library. But as a general language feature, there's there's not really a prescribed use case for these. It's sort of up to us as programmers in the Go community to really figure out what problems these things can solve. And when we're trying to solve multiple problems, or problems with multiple things, there's actually a very interesting paradigm that you have to contend with.
So a natural consequence of the fact that you get a single struct tag for one field is that if you want to use it to denote information for multiple libraries, you might run into conflicting values if multiple libraries want to use it and have different values for the tag. So that's where this incredibly useful convention of namespacing the tags has come from. This is purely a convention, and there's actually a really interesting, but it's worth mentioning that it's so popular at this point that all of the examples that we're going to show you from libraries use this exact method for namespacing the tag and do it as just a matter of course. We linked actually to a Google group discussion here among some of the hierarchs of Go, which is actually a really interesting read on how a popular language convention gets established. So there's a couple of interesting things about namespacing. So if you go back and remember the spec, namespacing is not there. There's no mention at all of how the string literal should be formatted. There's no mention of namespacing things in exactly this way. And there's a couple implications to that. The first one is that if you have a struct tag and you namespace things incorrectly, the compiler is not going to care. It's not going to catch it. It's going to run as normal, but you might end up with some really weird runtime errors when you actually try to use the tag. However, GoVet can catch these errors, so that's an incredibly useful thing to do a check against if you're using struct tags heavily in a namespaced way. Another interesting thing about namespacing is that even though it's not in the official language spec, it's such a useful convention that it is built directly into the official reflect package. This is what the code looks like for accessing the namespaced fields in a struct tag. Any library that's using struct tags is going to have some sort of code like this in it actually accessing the tag. So now that we've gone over what struct tags are, let's jump in with what we've at least seen to be by far the most common use case of them.
Right, so as I've talked to you guys here at this conference, I've gotten basically the same response of like, oh, struct tags, that's the thing you use for JSON. This is sort of far and away the most common usage of struct tags in Go today is for the encoding libraries in the standard library. So if you use the JSON package for Go, you can notice that the default behavior is to sort of serialize your JSON fields with the same exact name as your struct fields in Go. And this is a very elegant solution to that. It's really cool that it just works all right away out of the box. So you can see in this example, the H field is just serialized as to JSON as capital A-G-E, no modifications, just very clean. And that's fine if you're programming in a vacuum. But if you're using the JSON library, you're probably trying to talk to some endpoint or communicate with a different language, something with different naming paradigms, things like that. And so in order for the JSON package to be fully usable, there needed to be a way to map between Go struct fields and the fields in JSON that they're marshaled out to. Now, there are a couple ways they could have done this, right? There could have been some sort of runtime registry that you have to set these things on the fly, something like that. But luckily, the creators of the standard library noticed a great use case for struct tags in this. And so you're able to cleanly specify inside of your tag definition what exactly you want the JSON written out to. So you can see in this example, we have this sort of JSON full name for the name field, and then when it's written out, it's using full name instead of just the word name. Perhaps more interestingly, I think a much more compelling example is you can actually use struct tags to define not just the names, but the behavior of the JSON encoder. So in this top example with the ID field, you can see this omit empty string. And what that does is it tells the JSON encoder to not bother serializing out that specific field if it's sort of the zero value. So in this case, if it's an empty string, we don't write it out to the JSON encoding. And you can see in the example, we have this ID field that we don't specify in our literal. And when we serialize that out to JSON, it's not in there. Different encoding packages do basically the same thing. You just find similar behavior to XML. The bsin library, which is MongoDB's binary JSON format. And SQL ORMs also function in this sort of same underutilization paradigm. And for the BSIN and SQL ORM stuff, you actually end up having to contend with some different ways of coding and stuff that you have to deal with.
So let's take a slight tangent from actually showing different libraries that utilize struct tags and talk about how we solved a problem that we were having keeping string constants and struct tags in sync. And this is interesting because, first of all, it's a really cool use for us of struct tags, and it got us thinking about actually programmatically accessing struct tags and using them to do different things. So this is what code looks like for interacting with MongoDB via the Go driver. It's a really effective driver. It's worked great for us. And if you haven't used MongoDB before, Flatiron is essentially a table, and this is essentially doing a where query on where donor name, finding the entry where donor name is Selena Gomez. We're only using names that have the word go in it for our examples. Yeah. Seemed appropriate. So we would have these queries all over our code, and what would happen was that if we wanted to actually go in and change the name of the field in the database, maybe make it shorter, maybe make it clearer, change it for whatever reason, we would end up also having to update all of these queries.
Right, and there's sort of an obvious programming workaround for when you need to update multiple versions or multiple copies of the same string. You would just define the const, right? But that's still not totally ideal in this use case because we already have the definition in the struct tag. It would be great if we could just use the struct tag to build our queries.
So we ended up writing a library that would programmatically access the struct tag. Excuse me. That would programmatically access the struct tag and create the string constant based on the value of the tag. This is the GitHub URL for it. And the idea is that you call this must-have tag function, or must-have vson tag, we called it because it's getting the vson namespace tag, and it's getting the value of the tag for the name field in the donor struct. And this way, all that we have to do is actually update the actual value of the struct tag, and everything within the code will work correctly and use the appropriate string. And the reason it's called must-have is we wanted to emulate the regex must compile function where, if there's something wrong here, if the name field isn't in that struct or if there's no tag attached to it, that's that's programmer error, and we would want to fail immediately at initialization. We don't want any of our tests to pass. We want to make sure that we catch that as soon as possible. So now let's jump in with a slightly more unusual version of serialization.
Right, so previously we were looking at the sort of JSON encoding package, which serializes stuff to a byte array that you can then use for sort of external communication. But we've also found situations where we wanted to serialize our structs into Go built-in types. Specifically in this example, Go's map data structure. Right here we have the map structure library written by Mitchell H. It's a library for converting between structs and Go maps. And there's different reasons that you'd want to do this. The one given on the GitHub page is if you have a configuration or an encoding that changes slightly depending on specific fields. So in this example we have here, we're reading in this string interface map. You could say this is sort of what the JSON library might produce if you don't give it a type to marshal into. And so we have this sort of type switch here where we just read one specific field and then move our data into a struct once we know what struct to put it into. And this is nice because it can really simplify custom JSON encoding functions and stuff like that. Additionally, at MongoDB, when we were working on the continuous integration tool that I mentioned earlier, we've had use cases where we want to sort of read an entire YAML config file and then do some basic string parsing and substitution on that input before finally moving it into our final Go types where we can benefit from speed and compile safety and all that sort of thing. And this map structure package was a very clean and easy way for us to do that, and we benefited from it quite a bit. So that was one instance of configuration, but there's other ways that struct tags can help you with configuration tasks.
So when writing the tools, the MongoDB tools, we actually ended up using a different command line parsing flag package from the one that's built in, and the reason for this was mainly with backwards compatibility with the old tools, with exactly the way that the command line was parsed. So we ended up using the GoFlags package written by Jesse BDK, and An interesting aspect of this package is that it allows you to specify the mappings of command line arguments to values in a struct completely in the tag. So let's say you're building some sort of command line application to donate to a presidential candidate, and this donation struct might represent the different command line options that you want to pass in. So then you specify in the struct tag, okay, the short value of the flag is A, the long is donation amount, the description, and you can actually inline a lot of other stuff straight within the tag. We're getting to the point here where some of these libraries are going to become a little bit of a matter of personal preference, whether or not this looks good to you. We both think this is really clean. It's really nice to be able to see within the actual definition of the struct all of the information that you need. Some people might look at this and just recoil a little bit, and that's completely okay, but please try to keep your mind open as we move through other examples that could come down a little bit more to personal preference. So now let's pull away from mapping examples and go into our first declarative examples.
So this is an example of a library that allows you to specify sort of all non-zero default values using struct tags. It's called GoDefaults by Quadros. It's a really interesting sort of clever thing. In some ways, this is really clean because it lets you specify, right in the type definition what you want these default values to be, and just set them later with a single function. There are certain drawbacks to this that should be pretty obvious. For one, doing this loses all compile safety. The struct tags are just strings, so this could result in all kinds of runtime errors. But as an interesting thought experiment, we thought this library was really cool. Moving on the behavioral front.
So this is a library that we think is actually a really, really nifty and clever use of struct tags. It's called the Go Validator library, written by A. Saskovich. And what it does is it lets you specify within the struct tag how the actual corresponding field should be validated. So that when you call this validate struct function of the Go Validator library, it will make sure that, okay, the email field is a valid email address, or a well-formed email address, that this is a well-formed credit card number, etc. And this is another situation where it's really nice and clean to be able to actually just look at the struct and see not only what the fields are, but how you expect these fields to be passed in, and any additional validation of these fields beyond just type. So that's all of the libraries that we're going to show you that exist within the community. Now we're going to move on to some stranger thought experiments that we've come up with of other ways that you could potentially use struct tags. Starting with some more validation.
Right. So when we were trying to put this talk together, we tried to ask ourselves, what is the way we could use struct tags to just sort of blow through the boundaries of the language? So this library doesn't exist, and I don't encourage you to write it. But what we have here is sort of like an attempt at some kind of runtime type polymorphism in Go. Type polymorphism being shortly just the ability for a variable to have multiple types using these languages like Haskell. And you can imagine in this example that we have these empty interfaces, which are sort of how you would approximate this feature in Go. The empty interfaces excuse me. Empty interfaces are fulfilled by just about anything, but there's no way to put bounds on them. So in this example here, we have a type with different fields and different types that those fields are allowed to be, including some that could be user-defined. And then, in order to sort of work the polymorphism here, we'd have this validation that you run at runtime periodically to just make sure all your types are within those bounds. Don't do this. It's just to get the juices flowing, all right? As a continuation with a hypothetical that might actually be useful, we have this one dealing with foreign languages.
This is an idea that we actually think could be really interesting. As far as we know, there's no library existing that implements this, but the idea would be that maybe you have some sort of API that's being consumed by people that speak different languages, and you want to be able to serialize your responses based on what language you're provided. So it would be nice to be able to specify actually within the tag, if we're asked for a Spanish translation, let's use these field names. If we're asking for a Greek translation, let's use these field names, for instance. And now, let's move on to one that's very relevant to a topic that's been discussed a lot, actually, at this conference so far.
Right. So in the sort of zeitgeist of the Go community, we have this ongoing discussion about using code generation as a way to implement stuff like templating within the language. And this discussion has resulted in all sorts of things. We've seen the introduction of the Go generate command. We've seen just a huge variety of broad and very specific code generation tools crop up. And one thing that we've noticed with those code generation tools is that they generally rely on comments to tag, the specific parts of the code you want the generation to run against. In some ways, this is very intuitive. We already have sort of a paradigm of stuff like Go docs, which is reading your comments from your code and turning them into this sort of external documentation. And that's really slick. But there's sort of a mismatch when you do it for code generation, because Go docs, your comments just read like comments that you would have inside your code. Whereas using them for generation, you're basically putting in stuff, comments meant to be read by machines, not necessarily the perfect match for commenting. However, we do have a tag feature built into Go that, at least in some instances, could be applicable to this. Struct tags, and these are already meant to be read by machines, and so it kind of makes sense to try and use them as an interface for code generation. We have this example here. You can imagine this is a way to automatically generate sort of getters and setters for private fields, or possibly, and I think a much more compelling thing, we could emulate the behavior of the validation package we looked at earlier, but with compile safety, so in some ways we'd be getting all of the benefits of that package without any of the drawbacks. It would be much safer to use this. Finally, using struct tags for code generation would give you a reason to attach struct tags to unexported fields, which the language currently allows, but no external libraries can access them, so it's kind of pointless. And with that, that ends our examples, what you can, could, and might be doing with struct tags.
Yeah, we hope that seeing these has maybe got you thinking about using struct tags for something in the future that you might not otherwise use it for, or at the very least, if these were interesting or possibly amusing. Thank you. We do have time for questions. Yeah, don't worry. This looks like this is people.
Oh, yeah. Is there a maximum size for struct tags?
No. That's an easy one. Maybe the size of the memory on your computer.
Really good talk. Actually, that inspired something. Whenever you get requests, right? You have a request object. One of the things I thought of, and maybe there's a library where you give it the HTTP variable, and using struct tags, you can say that this is a required parameter, and then it just pretty much, just like json Marshall, I guess you fill in all the things. Do you think something like that exists, or?
I mean, if we said, our answer is just going to be a guess, but I think that would be a very cool way to do that, and it actually sounds like exactly the kind of thing you could use struct tags for. It's a really cool idea.
Cool.
But we have not seen a library that specifically does that.
Cool, thanks.
Hi. Can you go back to the Go default slide for context, maybe? You just passed it, I think.
Oh, sorry.
Yeah, so I'm curious about the example you have there, because if you have a new function, why wouldn't you just set the defaults there? What's the point of the struct tag parsing at that point? Especially, like you said, you kind of reach this place where now you have this weird type ticket that you're doing runtime type checking. So I'm just curious.
It's another situation where it really just honestly comes down to personal preference. There are some people might think this looks cleaner, or that would really like to see it within the tag. It's the argument. There's no real technical argument in my mind for why you use it.
Yeah, in this example, especially the example we have, I would not, for something this simple, I probably would not use this library. I mean, Go does have this very nice things like struct literal system that you can sort of do this with if you're writing a new function anyway. But we put it in there as an illustration of just sort of the behavioral things you can do with struct tags.
Well, sure. I'm just curious because, I mean, you spent the time actually putting a struct tag, a string that says the type. I don't know, you set the fields, so why not set the field, I guess? You said it's just a preference, but I understand.
We also might, using this in a new function might not necessarily be the best place for it, is you might want to do some sort of checking somewhere and then just be able to say, like, okay, for all these different structs, if there's, say we're part of some previous context, then we assume that they have some values, otherwise just like run through them and set the defaults for all of them, something like that.
Sure, thank you.
Hi, so you mentioned that all of this has convention and grown organically somewhat. Have you guys thought about like something being added explicitly to the language to support all these use cases of struct tags? Maybe like what is the evolution of struct tags now that people have started using it in this manner?
I think honestly at this point it would be nice if there was something a little cleaner than just specifying all of the struct tags in this namespacing convention all in one giant string literal. There's definitely, I'd say, an argument for if we want this to be a language feature that people use, just to be able to not have to run go-vet to see if the things are properly formed. I think at the very least that's something that could be done.
Hey, so along those lines, talking about that convention already being part of the standard reflection library, taking that over to your example of code generation, is there any existing place in static analysis right now that also parses that kind of convention?
I can't totally say. I know that I'm pretty sure you can access these from the AST package, but I don't know of any tools that are really working with it in that way.
Cool, thanks.
So the language itself restricts struct tags to fields. Do you know any methods or have you seen any patterns to attach metadata to the type itself that can be inspected at runtime?
Sorry, you mean just like you mean like a tag for the entire type rather than a tag for the individual struct?
Right.
I mean the field? Not in this way. I can't think of anything that existed.
No, there's no. I mean, you can have maps using the reflect package. If you need to store metadata to a type, you could sort of create a map of a reflect type to that string at runtime. But there's nothing just built into the language to let you do that, I believe. Which is why people are using comments for stuff like code generation, I think.
Actually, I was going to suggest that same notion, which is to extend the notion of the annotations to more than just the fields, but also to just types of them. Seems like nothing we won't get in.
Yeah, that would be an interesting thing to do. I think we might be needing some input on, from a language design perspective, on if that's a good idea or if that's the direction we want Go to move toward.
Yeah, I can see struct tags being a useful tool for making a generic persistence library that could bind to various backends. I was wondering if you know about any such library, and so could you recommend one?
A generic one?
How generic do you mean?
As much as possible.
I'm sorry. I didn't catch.
Can you repeat it one more time?
Sorry, could you repeat the question?
Right, I mean, it's hard to answer that right now, but as much as possible. I mean, perhaps not naming Cassandra.
I haven't seen anything that is that doesn't assume you're using a specific ORM or a specific database.
Thanks for this talk. It was really interesting to see all these examples. I can tell you that we put struct tags in for protocol buffers, which is the first encoding that we ever supported. And then using them in JSON and XML was kind of a natural next step. So they really work for encoding. It's really fascinating to see all this kind of non-encoding examples. The code generation was something that I had never seen before, which is cool. Someone asked about HTTP requests. There's an unmaintained old-coming package by me that is called WebServe, SRV, that you can Google for. It's on code.google.com, so get it quickly. And then there's the previous question about database stuff. I tried to do something like that for SQL. There's a DB store package also on code.google.com. but this was all very fascinating, so thank you very much.
Thank you. It was cool. It was wild, yeah. For our third purpose of this talk was maybe to coax some sort of response from the language designers about this. It's not a feature we talk about much.
I think you lost the mic.
Someone asked before about attaching to a type, right? This is something that's obviously missing. If you look at the XML package, we did this for the name, right? Because you need kind of the name of the overall XML element, and that should be attached to the type. But instead, we declared a dummy type called XML.xml name. And if you make that the first element of the struct, you can put a struct tag there and sort of interpret it as the tag for the whole type, which is just a workaround.